we move ahead to the next module of stationary waves. Students, in this module of stationary waves, we are going to learn a very important concept or a very important topic. This concept is of a vibrating string. Students, remember the derivations of this concept are going to be asked in examination for 4 marks. But currently, we are going to learn the basics of how there is a stationary wave which is actually formed on a vibrating string, or what basically is a vibrating string. So to start with the concept of vibrating string, we need to assume or take a string. Now this string is plugged at a certain point between any 2 rigid boundaries. With the help of these rigid boundaries, the wave remains between them and results in the formation of loop or segments. As you can see in the animation, we have the wave which is coming and striking the rigid boundary and then reversing back. This results, as we all know, in the formation of stationary wave, and there is a formation of loop or segments. So this is what happens if we pluck a string at a certain point between any 2 fixed rigid boundaries. And as this animation shows, we can see that the string is vibrating up and down. With the help of that digital meter, we can see we have set the string in vibration and string is vibrating. So we know that the string is vibrating with a certain given mode. We move ahead to study that if the string is vibrating, there must be certain wave which is set up in the string. Now what will be the velocity of that wave? To understand that velocity, let us consider a stretched string which is there under tension. We can see the rigid boundaries which are present, and there is a string which is there under tension. The string has a length L which is present. The mass density or the linear density of the string is given by small m, which is mass per unit length. Now you can see the string vibrating, there is a formation of this loop which is present. Now we know that if m is the linear density and L is the length of the string, then the velocity of the transverse wave which is produced on a string due to the plucking of the string is given by V is equal to under root of T by M, where T stands for tension and small m stands for linear density, that is mass per unit length. So students, we now move ahead to study about the vibration of string in detail. And to study it in detail, we must know something which is called as different modes of vibration. Now what are different modes of vibration? Any musical instrument, it produces certain number of notes. The vibration corresponding to each note is called as mode. And there are different modes of vibration of a string. Like we have first mode, second mode, third mode, and so on. So there are n number of modes for vibration of a string, because any musical instrument can produce n number of notes, hence there are n number of modes for vibration of a string. So let us study one by one each and every mode. The first mode that we are going to study is called as the first mode of vibration. You can see the animation. In the first mode of vibration, we can closely observe that the structure like this is formed if I have to represent in diagram. In this case, I can see that this is the basic mode of vibration, so I call it as the fundamental mode. I denote its frequency by N. Now for a string to vibrate in the fundamental mode, it needs to be plugged at the center. Again, the number of loops which are formed in this kind of vibration is only one loop. Also, we must know that this mode of vibration is called as the fundamental mode of vibration. Moving ahead, there is second mode of vibration which is there. As we can see in the animation, the second mode of vibration has a number of loops which are 2. So let me take the diagrammatic representation for second mode of vibration. In this case, the frequency is denoted by N1, which is greater than the N. How it is greater? That we will see in the derivations. So we know that For string to vibrate in the second mode, the string needs to be plucked at a distance of L by 4. Now you can see it is being plucked at a distance of L by 4. And while plucking, it needs to be held at the center as we saw in the diagram. So string needs to be plucked at a distance L by 4. At the same time, it needs to be held at the center. And when it is done, then there is a formation of two loops, and this kind of vibration is called as the second mode of vibration. We move ahead, and in this chapter this will be the last mode of vibration, that is the third mode of vibration. Yes, in the animation we can see that there are three loops which are formed. Now, three loops you have to represent in diagram. It will be something like this, and it will always have a frequency N2 which is greater than N1, that is greater than the second mode of vibration. So for string to vibrate in the third mode, it needs to be plucked at a distance of L by 6. And after plucking it, there is a vibration which is set up, and there will be three number of loops which will be formed. Again, students, remember, from this we can conclude so that if the mode goes on increasing, then the distance of plucking will go on decreasing. So students, with the help of this module, we studied different modes of vibration and also the concept of vibration of a string. Thank you.